So you guys. Okay, so we're the SWAT team, that stands for Solar Water Applications Team. Our goal was to design some sort of solar hot water system. The team consists of me, the team lead, Billy Hines. Rick Oliver was the scheduler. And then there was Kelly Roberts was the treasurer, and Jefferson Bellows was our quality and inventory control specialist. So that's our pretty faces there up on the screen. And like I said, the whole deal was to try to build, go along with the whole green building idea and bring some of that information into Weber State. Jeremy wanted us to be able to create a lab that he could use for the CMT and the DGT programs to kind of show how to incorporate some of this stuff into design. A big thing was to make a safe, hands-on environment to do the lab, and then also to show the efficiency or be able to compare a couple different types of solar systems. Okay. The first system we did was the evacuated tube system, and that uses glass tubes, which we got an example of one right here. You guys would like to pass one around. So, and the glass tubes, that one there, the solar insulation's been removed, so you can see what's inside of it. But there's a copper tube inside of it that has a little bit of fluid inside of it, and as that fluid heats and expands, the hot steam inside the tube goes up into a manifold, and that manifold heats the glycol as it passes through. The other system that we did was a drain back system using a flat panel. And again, we got another example of one of those here. I'll add that to you. So, and with that system, the water is pumped up from through the bottom, up through the panel. It heats as it goes through the panel, and then is put back into the tank. This tank is only about half full. There's actually air in this system. And the reason for that is, as you're circulating the system, if it's cold outside, you don't want it to freeze inside the lines. So as this pump shuts off, there's a slight angle, drain angle, in the way you set up the panel, and that allows the water to start draining, and then a siphon effect starts. And we decided to put in a clear plastic tube so you guys would actually be able to see that siphoning going on. And then the other part of the deal is we had to be able to set these panels up to where they had the proper angles. And in order to do that, we had to modify and create some adjustment points on the existing brackets that came with the panels. And the brackets are currently set at the 41 degrees, which is just an optimal. It doesn't really matter what time of year you could use that angle. But it also will adjust down to about 26 degrees for summertime, so it points more up. And then all the way up to about 70 degrees, 68 to 70 degrees in the winter, so that it actually shed the snow easier as well. So, and then with this whole lab, the whole basis behind it all was Jeremy Farner had gotten a grant for us, and he wanted to be able to teach this, like I said, in some of his classes. So we had to have it fit inside a storage room downstairs, and those are the measurements of that storage room. We wanted it to be light as possible, easy to drain and fill. One or two people could set it up so that if Jeremy had to do it by himself, it all worked out real well. We also had to accommodate any of his requests as far as he wanted to be able to create a lab in the future for it, an actual lab book or whatever. And we wanted to be able to have it do as much stuff as possible so he could create a sufficient lab. And then we had to stay under budget. So. And to talk a little bit about how we put it together, here's Jefferson.
Hi there, my name's Jefferson. One of my responsibilities this semester was to keep track of inventory of the majority of the system componentry as well as hardware. In our two separate hot water systems, we have approximately 386 individual components built into the cart. As far as the inventory, the way I accomplished this task was working closely with Kelly, the purchaser, and also by reviewing carefully all of our receipts as we made purchases and returns. As far as some of the returns we made, one of our first ECOs was great simplification of both systems as opposed to our 3D models from last semester. We were able to remove quite a few of the 45 and 90-degree elbows, which we therefore could return to the store. We got about $1 each for those. Another ECO that we came up with this semester was eliminating a lot of the hardware in the floor pan of the cart. The floor pan of the cart has two 1/8" sheet metal sheets, and in our initial model last semester we had 28 5/16 volts hardware holding the sheet to the cart, as well as the expansion tank brackets to the sheet. We decided to eliminate all of this and instead stitch weld everything. This eliminated quite a bit of time in fabricating and drilling all of the holes, as well as material costs. We were able to return quite a bit of the bolts, nuts, and washers. And then this slide here, basically me being the sole MFET student on our team, I was responsible for all of the cutting, welding, and fabrication on our car. 3 items I'd like to discuss that were donated to us by the school. One is the cart itself. One was some plastic handles, and another is casters. As far as the first unit, the cart we were supplied by the school, the overall height and length of the cart met our voice of the customer requirements provided to us by Jeremy as far as the storage space and footprint. So last semester we were able to do all of our 3D modeling and incorporate both of our systems into this cart. However, it was too wide, so I was responsible for sectioning the cart down from 36 inches down to 28 inches so that it may fit through any doorway here on campus. The next item I'd like to discuss is with the trailer jacks here. As you'll see here in the slide, the base plate on the jacks actually extend past the cart about 2 inches on each side, so that takes it to 32 inches, well within our 35-inch allowance. Next time I'd like to discuss is the handles. If you recall from our presentation last semester, we did some FEA analysis on our plastic handles. We did come up with a determination that they were plenty strong for our requirements of transporting the car. However, we needed to come up with a unique storage solution for our 100-foot power supply cable, as well as our 100-foot water supply hose. We therefore eliminated the plastic handles and built a 3/4-inch pipe handle that would provide a unique solution for us to roll up the hose. You'll see later on. Another ECO, unfortunately, as you can see here, the handle unfortunately interfered with the trailer jack handle, and so all we did is we relocated it from the corner gusseting up to the higher top tube. Last one I'd like to mention is the casters. We were provided also 5-inch diameter hard plastic casters from the school. They were used, they were 325-pound rating. We decided to instead replace those with a heavy-duty cast iron caster with a 400-pound rating with the thick rubber durometer tread. We decided to use these to better negotiate the expansion joints in the sidewalk once it's fully loaded with all the water. As far as the general fabrication and assembly of both systems, we all participated in this activity. We all participated in soldering a lot of the copper plumbing and tubing, and everything went together pretty well. As far as the paint, we were going to have the automotive department primer and paint the cart for us, but to save a substantial amount of time and money, we decided to instead primer and paint the cart ourselves. I'll turn it now to Rick to discuss some of our scheduling.
So I was in charge of the scheduling each semester. And we kind of had a hard time the first semester with our scheduling. We didn't really keep track track of our tasks. So basically what happened was we kept a lot of the design and the drawings and that sort of thing until the end of the semester, and we were rushing to get everything done. And so luckily we learned from that, and this semester we changed up a few things as far as the scheduling went. One thing that we did that I think helped a lot was we set up a day each week that we were all required to come and spend 4 hours that day to work on the cart, to work on the fabrication or the assembly of the cart. And so how it worked out, I mean, the Friday was the fabrication day, so Kelly and I would come in the mornings, and we came at 8 o'clock. And we would work on more of the simple things like the setup, cutting, grinding, that sort of thing, so that we could prepare that day's activities for more advanced items like soldering or welding. And we usually stayed until about 1 o'clock, and Billy and Jefferson would come in around 11 o'clock and work until 3, and they were in charge of the more advanced part of the build. And then we had some overlap there, and it actually worked out perfect. So at 11:30 we would have Jeremy come in, and that's when we held our weekly meeting with him. And there we were able to kind of fill him in on what we had done that previous week and what we were going to do that next week. And so like I said, the schedule kind of drove this semester versus last semester, and I think that actually helped us out quite a bit. Communication was important. Last semester we didn't communicate well with each other. There was kind of, different groups that would work together and not really communicate with others. And so what we did to help communicate with our communication on the scheduling was, of course, the schedule itself, but we also just kept a large calendar on the desk where we would jot notes down, just kind of letting each other know what needed to be done or what we had already done. So that helped our communication. And there were a few setbacks. The biggest setback that we had, I think Jefferson mentioned it, were the leaks. As soon as we started pressurizing the systems, leaks started to spring up. And so we spent a lot of time trying to figure out, resoldering, trying to get those leaks to stop. And there were some fittings that were wrong, so they had to go down to the store, and we were about 2 weeks behind on that because of that. So like Jefferson said, one of the things that we did to kind of catch ourselves up was to just use rattle cans. We just spray painted the cart versus take it down to the automotive department. And one thing that also affected, that setback affected, was the time that we had to thoroughly test the system. We had set aside roughly 2 weeks or so that we could take the system outside, run it, put it under the sun. And so we kind of suffered there, but we were able to kind of speed things up. We just took a torch and heated the systems up with that, and then we were able to determine that each system worked accordingly, that the leaks were. And I was also in charge of the documentation. Two of the main documents we had, see the user manual and the ECOs. The ECO, or we call it a change request, was pretty simple. Up in this corner, we would put the request number, who it was requested by, the revision of the old, revision of the new. We'd have a short description of what was happening and a reason for the change. And we would also include the drawings with that as well, the drawings that we had changed. And then at the bottom we had our approval and our sign-off. And then we were also required to create a setup manual. And what the setup manual is it allows Jeremy each semester to kind of to use to set up the system each time he uses it before the class uses it in the lab. And basically what it entails is it shows you how to pressurize the system, how to fill it with water, glycol or whatever it may be. It also includes kind of a safety section, just kind of let you know what to do and what not to do to keep yourself safe. And that takes care of the documentation. I'm going to turn the time over to Kelly to talk about our budget.
Thanks, Rick. Like Billy mentioned at first, I was in charge of the budget / purchasing of the project. At the first of last semester, we required a grant from the Department of Energy for $4,545, which we used into the purchase of the components. We also received a generous grant from Dean Warren Hill, and we appreciate his support and his staff for their support. This semester we had a few hiccups in the budget. Last semester we had to buy everything, so I'd mistaken and forgot to add one component onto our price list, which we noticed this semester. By doing that, we were over budget by $40 compared to being under budget of a couple $100. This semester I've learned that teamwork really helps the team in the senior project. You're able to reach your goals, to achieve the dreams and the requirements of your client. I want to talk a little bit about a personal experience that happened last semester. For those that know, last semester, my senior project wasn't a high priority on my list. I thought the senior project was a waste of time, and my attitude kind of reflected that. The team members here, and also some of the faculty and staff that noticed this, saw what I was going through and sat down and talked to me. They told me, you have two choices to make. You can either succeed or you can fail. And I started thinking, I'm like, wow, senior project really is important. It ties everything together that you've learned throughout your time at school. I'm like, I want to succeed. I want these guys to succeed. I think our project should succeed. And once I made that decision, I've talked to those that had a hand in it. I talked to them. I'm like, I know I don't have your trust right now, but I promise you I will earn your trust by the time the semester is over. And I worked on that. And by doing so, I think I've earned everybody's trust, and I think everybody's seen a change in my attitude. And I thank you for the opportunity that I have to be on this team and to learn the things that I needed to learn. Now I'm going to turn the time over to Billy and allow him to finish.
Real quick, I'd like to thank Kelly. Everything was so much better this semester. He did a complete 180. He did a great job, and I think we all need to congratulate him on that. He did awesome. I think with all this going on, he didn't talk much about what the budget is he had been preparing in the past, but he did a really great job, and I can tell you right now that he more than made up for it this semester. He spent every spare time he could purchasing, ran out all the time to get stuff, even between breaks at work and everything, so it was really awesome. So, and now if you guys are ready, we'll head outside and demonstrate how this works, kind of show you where we had some of our issues. We're at the end of the machine shop. We had to move everything down there, so we'll be in the sun.